Hello, welcome to Z Talk. This session, I'd like to continue on where I left for Terraform. In the previous two sessions, we were able to spinning up EC2 instance with Nginx provision on it, and we were also able to create a custom VPC with 3 subnets. If you want to review the configurations, please take a look at my previous two sessions for Terraform. I attached the link above and in the description. Today, I will continue on modifying those existing configurations so that the new build EC2 instances will be running on the custom VPC that we have built. Here's the plan. I'm gonna create security groups and use key pairs to log in the EC2 instances. In the AWS machine, up to 5 security groups can be attached to a single instance. So let's build 2 for testing. One is for enabling SSH and the other is for enabling HTTP. And next, I will define the traffic rules in the security group. There are 2 types of traffics we need to manage. Ingress, which is the inbound rule, manages the traffic that comes to the instance, and egress manages the traffic that comes from the instance to the outside. I'm gonna need port 22 enabled so that I can SSH to the instance once it's up and running. Meanwhile, port 80 is also required to open as Nginx will be provisioned along with the instance, and I need to be able to access the Nginx from my laptop. Okay, we got the plan. Let's jump to the demo to modify the code. I will use the existing code base that I created in the previous 2 sessions. Before I jump to it, sum up my video, subscribe if you haven't done so. More importantly, leave comments if you have any questions. My purpose for doing this weekly is simply to know more DevOps engineers to share experience. All right? Cool. Here is the code base that I've created in the past 2 Terraform sessions. Basically, they were for spinning up EC2 instance and creating custom VPC. I will go through one by one real quick at high level. But again, if you want to review in detail, feel free to jump back to my previous session first. And once you understand all the details, you can go back. So I'll start with VPC.terraform. So basically, it defines the custom VPC and the 3 subnets that will be attached to that VPC. And I built 2 public subnets and 1 private subnet. I also defined internet gateway. So for the public subnets is able to talk to the internet and route table and associate the route table to the 2 public subnets. The next one is net.tf. It was pretty much for the private subnets. You can see I defined the external IP and NAT gateway, and NAT gateway will be running on the public 1 subnet. And I also defined the route table and associated route table with the private subnets. And there were another 2 config file providers.tf and variables.tf. They will basically store my AWS account information and those variables that defined to store like access key, private key, the default region, and all those kind of information. And the last one was create instant.tf. That was for spinning up the EC2 instance. And you can see I defined the image that I'm going to use for that EC2 instance and key pairs for getting access to that EC2 instance. And inside of the instance block, I put in provisioners because once the EC2 instance is up and running, Terraform will provision Nginx software on it. So it have to connect via SSH to the EC2 instance, and perform, basically read the file, the install nginx shell script that I prepared ahead of time. Here is pretty straightforward, right? Just run the apt-get to install nginx and start nginx as a service. That's pretty much it. Now let's follow our plan for this demo to add the configuration so that once the EC2 instance is being built, it's going to build on the custom VPC that we have created, right? So, and I will create a lot besides these instance, EC2 instance. I will create another one and have these two instances running on different subnet. I plan to have one running on the public subnet and the other running on the private subnet, so that we can verify shortly if those security rules, security groups we gonna create works or not. Okay, let's do it. Okay, in the create instance.tf, you may notice I already added another resource block for spinning up another EC2 instance. Basically, inside of these resource blocks, the configuration is exactly the same like the previous instance. It's going to use the same image and will be running in the same availability zone, right? And now I need to create another configuration file for security group where I'm going to define the traffic rule for inbound and outbound, and so that we can attach that security rule to the EC2 instance here. Let's jump over there and create a security group rule first. So again, the Terraform documentation is going to be our Bible. Let's just Google AWS security group, and it directs you to these Terraform registry documentation. And here it shows the syntax of these module, right? Just refer your configuration with this guy, and you should be good. So let me jump to the Visual Studio Code. So I'm gonna create this resource, AWS security group, and give a name, description, and VPC ID. And after that, I'm gonna define my role for both ingress and egress. That's the plan. Here, let me start with the resource. Resource, AWS security group. And the name, I will call it allow custom VPC SSH, right? And VPC ID will be the one I create in the VPC.tf. So it's gonna be AWS underscore VPC dot the variable name is custom VPC. So copy that and jump back to here and paste that and .id, right? And give a name. I will use the same name as the variable, allow custom VPC SSH, and give a description. This is the security group that allows SSH connection. All right. Now let's define the ingress. Not this. We need to just make it easy. I just copy egress, and paste it here. So I'll start with ingress and the from port and to port. As we only gonna enable SSH, so we just put port 22, which is the default port for SSH, to both from port and to port. And protocol is TCP and CIDR block. Okay, setter block here for demo purpose, I just gonna use 0.0.0.0/0. Basically, it means every single IP across the board. Apparently, for your production environments, your real environments, this is gonna be a security vulnerability. So you have to define the specific IP ranges that's allowed to talk to these VM, right? Same thing for the egress. But for me, since it's just demo, I just use everything, so it's easier. And for egress, since this is the traffic from the EC2 instance to the outside, so it should be okay. We just allowed everything, so that's why I choose ports as 0. That's the value means every ports, and protocol, the -1 value means every protocol's available, right? So that's pretty much it. Next one, I'm gonna create another resource, a security group resource to allow HTTP for the Nginx. So it's gonna be pretty much the same. So I just copy the whole block here and paste here. All I need to modify, I just give it another name. This was SSH. I'll change name to HTTP, and same custom VPC, and change the name from SSH to HTTP. And description, security group that allows HTTP connection. And here in ingress, I would change the port to port 80, the default port for HTTP, and the rest is same. All right, and let's double check the format here. Okay, here, tags. So let's give a tag. Seems I didn't give a tag here for both resource block. So I will give a tag and give a name. So for the first resource block, the name will be same thing, allow custom VPC SSH, and here for this guy, I'm gonna give a tag, same name, allow custom VPC HTTP. All right, that's pretty much it. Now we have the security group in place. We can go back to create instance configuration to add the security group to the EC2 instance. Yeah, so in the first instance resource block, what I need to do, I need to, after the key name, I will add another parameter, VPC _ security group ID. We basically, I just need to attach the group ID that I created in the security _group.tf to here, so they can correlate, right? So here I'm gonna use AWS security group dot the variable name. Let's jump back here. The variable name one was allow custom VPC HTTP. The other was allow custom VPC SSH, right? So click here. .id, and the other security group, since it's the list, right? So we can put multiple. Remember, each EC2 instance supports up to 5 security groups, so 2 should be fine. So I will allow Same thing, it will be AWS _ security group dot allow custom VPC / HTTP dot ID. All right, and next, after we added the security group, another thing is we need to add the subnet. So we need to define, okay, these instance will be running on which subnets that we defined earlier, right? So we'll put subnet ID, and as planned for these, the first instance, it will be running in the public one subnet in the custom VPC that we created, right? So here we just put in the AWS _ subnet dot, let's see, VPC. Here we define the subnet, right? I'm gonna use custom. Let's use custom 2, this subnet, public subnet. So I'll copy that. So custom VPC - public -2. So these instance will be running on these subnets, public 2 subnets dot ID. Cool. And then same thing for the other instance. I will copy these 2 and paste it down here. The difference for the other instance, I will have them run in another subnet. Instead of public 2, I will have it run in private subnet. What do we call the private subnet? All right, custom VPC private -1. So I will copy that and paste it. So paste it down here. Private one. So once these second instance will be running on these private subnets. Okay, and for the security group, since these we're not gonna SSH we do need to add SSH, but we do not need HTTP because Nginx will not be running on this instance. Will be running on instance 1. So I will just take this security group out because we only need to be able to access SSH to this instance. That's pretty much it. Let's save it. And now we can go ahead to let me jump to my terminal and since we have new files created, let's firstly run Terraform init and then issue Terraform plan to see if there is any error pop up. Okay, looks good. You can see there will be 17 resources to add it, and basically just for the subnet instance and all of those like associations, basically the component we define in all of those config files, right? So we're good. And then we can go ahead to issue the Terraform apply to see how it goes. Okay, let me clean up my terminal and issue Terraform apply. Type yes to approve, then let's wait for it. Meanwhile, let me jump to my AWS portal and EC2 instance and 0 running instances right now. Let's see once it's installed and let's compare. and also take a look the VPC and cool. You can see it's connected. The first EC2 instance was already spinning up. Is connecting to that SSH and execute that shell script to install Nginx, right? And looks good so far. Let me jump back to the portal and EC2 instance. And see here, it's already two running instance out there. Let's jump back to my terminal and wait for Terraform to finish this task. Okay, apply complete. Resources 17 were added. Looks good. Let's come here verify. So you can see there were two instances up and running, and the first one is the one running in the public subnet. So you can see the private IP is 0.10.0.2.31. That's exactly the subnet range, that the CIDR range we defined, right? So let's go back here to verify inside. Because in the create instance for the first one, we have these instances running on public 2 subnet. So let's see public 2 right here. Let's see the CIDR range for public 2. So for public 2, the CIDR block is 10.0.2, right? So that's exactly the IP here, 10.0.2.31. Looks good. And you can see for security group, allow custom VPC SSH and allow custom VPC HTTP were attached to this instance. Cool. And we can use this public IP to verify, since the Nginx software were in provision on this box. So if we, and also since the these allow custom VPC HTTP security group was attached, we should be able to get access to Nginx from my laptop. Let's do that by opening a tag and put the IP here and hit enter. See here, we were able to get access to the Nginx. Cool. And let's take a look at the other guy, and he's the instance 2, and see, because the instance 2 is running on the private subnet, so there was no public IP assigned to this instance, and it's in this IP range, 10.0.3. That's exactly the CIDR block for private 1. You see that? 10.0.3.0/24, right? Looks good. And the SSH and the SSH rule was attached. And remember, we didn't assign the HTTP, so looks good, right? Last step, let's perform some validations to make sure the security group that we created works as they're supposed to be. Let's take a look at the ingress role under allow custom VPC HTTP security group. Currently, the CIDR blocks for ingress is set as all IPs, which means I can get access Nginx that was installed on EC2 Instance 1 from anywhere, both inside and outside of VPC. Let's verify that by logging in from my laptop, which is outside of VPC. Let me grab the public IP and open another browser, hit enter. Yes, this is the home page of Nginx, so I was able to get access Nginx from my laptop. And then we jump to EC2 Instance 2, which is hosted on the private subnet inside of the VPC. I should also be able to get access. We can test it out via curl command. for SSH to EC2 instance 2, I need to SSH to instance 1 and then use instance 1 as the jump box to SSH to instance 2 because instance 2 is hosted on the private subnet, which does not have direct connections to the outside of VPC where my laptop locates, right? So since both instances use the same key pair, I will use agent forwarding to connect both instances. So let's jump to my terminal, and here I'm in the directory where I store my public and private key here. So let's firstly issue SSH add to add my private key here, hit enter. So now let's SSH to instance 1 by issuing SSH -a. The user ID is Ubuntu and the IP is the public IP. Hit enter. So now I'm on instance 1, and from there I'm gonna log in instance 2. Let's check the close the out. Let's check the IP address of instance 2, which is 10.0.3.248. And let's jump back to instance 1 and do the same command, SSH Ubuntu, because both instances use the same key pairs and same user ID, right? So hit enter. Now I jump to instance 2, right? Here, let's do curl command, and let me grab the IP address of instance 1, which is 10.0.2.137. So copy that. I should be able to get access Nginx. Here we go. So you can see the homepage of Nginx. So looks good. Now let's jump to the second scenario. Let me go back to my Visual Studio Code, and I will change the CIDR blocks from allow all IPs to only allow IPs in the virtual private cloud in the VPC. So for doing that, what I can do is here. So the CIDR block will be the VPC custom VPC CIDR block. Now what we should expect is I should not be able to get access Nginx from my laptop anymore, but I'm still should be able to get access Nginx from the EC2 instance, which is inside of the VPC, right? So let's test it out. Let me save this change and apply this change. Let me open another terminal and go to that directory is in Terraform, AWS. Okay, so let's issue Terraform apply to apply this change. Yes, to approve the change. Okay, the change was applied, and now let's try it out. So firstly, let's try to get access from my browser. On the laptop, we should not able to log in these and get access Nginx anymore. See? So I cannot get access Nginx anymore from my laptop, but I'm still able to get access Nginx from EC2 Instance 2. let me run the same command, hit enter. See, I can still get access Nginx, right? Cool. That's the test scenario 2. Let's jump to the last test scenario. Let's change the let me go back to my Visual Studio Code, and let's change the CIDR blocks again. So now instead of allow IPs for all the VPC network, let's scale it a bit down to the subnet level. Let's only allow access from the same subnet which EC2 Instance 1 locates. So let's go back to the VPC. So the EC2 Instance 1 is hosted in the public subnet 2, right? So let's copy this one. So let's copy this CIDR block and replace this guy to this subnet. Now, what we should expect is we should not be able to get access Nginx from neither my laptop nor the instance 2 that is running on the private subnet, because I only allow ingress from this CIDR block, which is the public subnet 2, right? So let's verify that. Let's go to terminal, apply this change first. All right, so now let's try that again. So firstly, same thing, tried it out. Same IP from my browser. I should still not be able to get access Nginx from my browser, right? I still cannot get access. Then let's jump to EC2 Instance 2 on the private subnet. For this case, I should not be able to get access Nginx either. So let's hit enter. See, I cannot get access to this homepage anymore by curl command. Cool. That's pretty much verifies that we can say now, or the security group we create works as expected. All right. That's pretty much what I want to share for this session. Thanks for watching, and see you next time.
Alright, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.